Welcome back. In today's lesson, we're going to start talking about application of systems, meaning word problems. How can we model and solve problems using systems of equations? And there are three specific types of problems that systems fall into. So we're going to do three different examples of three different types of modeling. So example one has two situations. It has a video streaming service, Atomic Stream, and they charge $10 for membership and $1 for each movie downloaded. That's important information, so I'm going to highlight that. They charge $10 membership and then $1 per movie downloaded. Blitzstream charges $15 membership and 50 cents per movie download. So I'm going to highlight that because that also seems like important information. And the question is saying how many movies would you need to download? So I need to figure out how many movies would I need to download for the services to be identical. And that word identical is really important, okay? Because when we think identical, we think the same, we think equal, okay? So I'm going to kind of put like a little equal sign right here because that's what my brain goes to is when identical, they're equal. So I want to know how many movies you need to download for the services to be equal and what is that cost. So first, let's analyze the information. So I've got this Atomic Stream. And they're going to charge me $1 per movie. And they're going to charge me just a $10 blank fee. I've got Blitz. And they're charging me 50 cents per movie with a $15 fee. So that's the information I know. And so I want to formulate a plan because there's two things I don't know. I don't know what how many movies there are, and I don't know what the cost is. So those are my two variables. So I'm going to let X be movies. Actually, you know what? Let's make this a little easier. Let M be movies, and let C be cost. Sometimes it's good to pick variables that match the words that you're looking for, okay? And now I need to sort of create some equations for this. So Atomic, if I were to make an equation for this, I could say that the cost is going to be equal to that $1 per movie, so 1M, plus that fee of 10. And that's the hardest part, is writing this equation, right? You know, cost equaling that $1 per movie plus the $10 fee. I took away the dollar signs, I took away the word movie and fee, and I replaced it with C and M. I can do the same thing with Blitz. I can say that Blitz, the cost is equal to 50 cents per movie plus a $15 fee. And then my plan here is to set them equal to each other. And I'm doing that because of this word identical. When will the costs be identical? That's what I'm saying, them equal to each other. So I'm going to go ahead and solve this. I'm going to go ahead and say, okay, well, here is C equaling 1M plus 10. Here is C also equaling 0.5M plus 15. So my plan can be, all right, 1M plus 10 equals 0.50M plus 15. There's my atomic right here. And there's my blitz right here. And I'm saying, when are they going to be the same? And now I can go ahead and solve this equation like we would any other equation that has a variable in it. So I'm going to go ahead and subtract the 0.50M on both sides. This is going to give me a 0.50M plus 10 equals 15. Subtract the 10 over. 0.50M equals 5. Divide both sides by that 0.50. And I get that M is going to equal 10. Okay, so now I know that they're going to cost the same when I buy 50 movies. Okay, they're both going to be the same cost, but I need to figure out what that cost is. So I'm going to take that m right here, this m equaling 10, and I'm going to replace it with the m in one of the other equations. I'm going to pick the one that doesn't have the decimal point. I'm going to go ahead and pick atomic. So 1m plus 10 equals c. So I'm going to go ahead and say c equals 1, but instead of m, I'm going to put 10 into there. So the cost is 20. And then we want to write a sentence to display that, like to explain this information. So you can say after 10 movies, the cost is the same. Okay, so c equals 20, m equals 10. Okay, that's the first type of problem. And I like to call these problems the y equals mx plus b problem, because both your equations are like y equals mx plus b. You've got a variable equals something times another variable plus a number. So I like to call these the y equals mx plus b problems, okay? Let's take a look at the second type of problem, okay? The Maths Club and Science Club had fundraisers to buy supplies for a school event. The Math Club spent $135 buying 6 cases of juice and 1 case of bottled water. That information seems important to me, so I'm going to highlight that. The Science Club, spent $110 buying 4 cases of juice and 2 cases of bottled water. That also seems like important information to me. How much did a case of juice cost and how much did a case of bottled water cost? So those are my 2 unknowns. How much is a case of juice and how much is a case of bottled water? Okay, so I'm gonna go ahead and kind of summarize my information. So the Math Club spent $135 and they had 6 juice and 1 water. The Science Club spent $110 and they got 4 juice and 2 water. So there's kind of my summary of information. What don't I know? I don't know how much the juice costs and I don't know how much the case of bottled water costs. So those are going to be my variables. So I'm going to say let J equal juice cost and let W equal the water cost, because I don't know what those 2 things are. Okay. Now, when I go to find my equation, the nice part about this problem is that I'm adding costs together. I'm adding the cost of the juice plus the cost of the water, and I'm spending a certain amount of money. So in the case of the Math Club, I'm spending $135 on 6 juices and 1 water. So when I write that equation, let me get the right pen. The Math Club is going to have an equation of 6J plus 1W equals $135. The Science Club spent $110 on 4 juice and 2 water. So the Science Club had 4 juice plus 2 waters equals $110. So there's my 2 formulas. Okay, and when I notice this here, when I notice this set of formulas, I'm putting a box around it because I think it's important here. I notice that the variables line up. And if the variables line up, I want to use elimination to solve this. So I'm going to go ahead and rewrite this over here at my under solve. So 6J plus 1W equals 135, and 4J plus 2W equals 110. I'm going to go ahead and multiply this top equation by -2. And I'm doing that because that will cancel out the W's, like we've done an elimination in the past. So this becomes -12j minus 2w equals -270. And on the bottom, I'm going to leave my equation the same. And notice now I've got it set up where if I add these equations together, those cancel out. I end up getting -8j equals -160. Divide both sides by -8, and I get that j equals 20. Okay, so this means that a cost of juice costs $20. So now I know that the case of juice costs $20, but I still don't know the case of the water. So I'm going to go ahead and take this 20. I'm going to rewrite. Let's just do the top one. So 6, but instead of the j, I'm going to put a 20 in there. Okay, that's going to give me 120 plus 1w equals 135. Subtract the 120, and I get 1w equals 15. So that means a case of water equals $15. Okay. So now I can rewrite this and say a case of juice is $20 and a case of water is $15. So it's the second type of problem that we're going to be working with. Okay. And finally, we have one last type of problem, and I think this one is the trickiest one. I think this one's the trickiest one because the numbers aren't as obvious as in the others. We kind of have to make some assumptions, but let's take a look. Members of the Blue Valley West senior class held a car wash to raise funds. You know what? Let's change that to Blue Valley High because that's where I work now. So members of the Blue Valley High senior class held a car wash to raise funds for the prom. They charged $3 to wash a car and $5 to wash a pickup truck or an SUV. They earned a total of $275 by washing a total of 75 vehicles. How many cars did they wash? So I'm looking at the information. All the information is important here. But I'm noticing that it's $3 to wash a car, $5 to wash a pickup truck or an SUV, and they made $275. Okay. I think that that's a really important piece of information. So I'm going to go ahead and write that down a little bit over here. I'm going to say it was $3 per car. It was $5 per truck for a total of $275. The other piece of information I know is that they washed a total of 75 vehicles. So that's my other bit of information. So they washed a total, and when I think total, I think adding 75 vehicles. So that's me summarizing the information. Now, if I want to formulate a plan, I need to figure out what I don't know. I don't know how many cars they washed altogether. And I don't know how many trucks they washed altogether. So I'm going to go ahead and let C be cars. And I'm going to let T, and I make a little curl with my T because otherwise it looks like a plus sign, let T be trucks. And we're going to have two different equations here. We're going to have this equation that has this information, and all of this information has money in it, has dollar signs. So when I want to write this equation, I can say, well, it's $3 per car plus $5 per truck, and they spent a total of $275. Notice that all the numbers in here have dollar signs in the original word problem. That's important to be able to put your first equation together. The second equation is a little bit trickier. The second equation has to do with washing a total, adding 75 vehicles. If I'm adding all the vehicles, I need a plus sign. And I'm basically taking the cars and the trucks and saying, hey, all together, I washed 75 of them. I call this one the counting equation. It's nowhere in the problem that says cars and trucks make it equal to 75. You've got to look at this washing a total of, especially this word total, is your clue that I'm going to need a counting equation. I'm going to need to add the two things together and get whatever the total is, okay? I also notice that this problem, the variables line up, so I'm also going to use elimination. You could use substitution, but it's a little bit trickier. So let's go ahead and rewrite this. 3c plus 5t equals 275. C plus t equals 75. And I'm going to go ahead and multiply this bottom equation by -3. When I do this, the top equation stays the same. But the bottom equation is -3c minus 3t equals -225. When I add them together, I get 2t equals 50. Divide both sides by 2, and I get the total amount of trucks is 25. I don't know how many cars yet. I'd only found trucks, and that's sort of the question they're asking. How many cars did they wash? So now I've got to take that 25 that I got here and plug it back into one of the original equations. And I'm going to pick this equation because it's way easier to plug into. All I need to do is say C plus 25 equals 75. Subtract the 25 on both sides, and you get C equals 50. So they washed 50 cars and 25 trucks. Okay. I know word problems are overwhelming. I know they're challenging. I know they can be very tricky and scary. I'm here to help you. You've got lots of ways to get help. I know it could be a struggle, but we can do hard things. So good luck, and let me know if you need help.